Now we're going to talk about gas evolution reactions that we mentioned a little bit earlier. So here we have two aqueous solutions and a really loud train. Good grief. I could start over, but I'm just going to leave it. Gas evolution reaction, you get two aqueous solutions mixing and they're going to form a gas, which is usually seen as bubbles in the solution. The gas can be formed in a couple of different ways. It can be formed from an ion exchange, where this is like the predicting products for a precipitation reaction. We're going to take the potassium, the sulfide, the hydrogen ions, and the sulfate, and we're going to switch partners and see what we end up with. And what you end up with is K2SO4 and H2S. H2S is a gas. How do you know that? Well, I don't really expect you to know it at this point. H2S is a gas. Other reactions will form by the decomposition of one of the products. But again, it's the ion exchange. So here we have sodium hydrogen carbonate and HCl. So we have the sodium and the hydrogen ion swapping places. So we end up with NaCl and H2CO3. Well, we just have to learn and remember that H2CO3 is not stable. It decomposes. It decomposes to form water and CO2. This is an illustration of that. So here, NaHCO3, sodium hydrogen carbonate, also known as baking soda. You mix baking soda with an acid, and you're going to get water and sodium chloride, and the carbonic acid, as it's formed, will decompose and make carbon dioxide bubbles. And so you'll see this fizzing. So there are 4 products that you should remember in association with the gas evolution. So if you get H2S as a product after swapping ions, H2S is a gas, just because I told you just now. If we swap ions and we get H2CO3, we need to remember that that's unstable and that it decomposes. Something that looks very much like it is H2SO3, also unstable. And then this guy that looks nothing like it, NH4OH. And I want to show you how it's pretty simple to figure out what gases you get. So let's look at the H2CO3. When that decomposes, it's going to lose water. It's going to lose H2O. So if we lose the H2O, that means I get rid of the 2 H's there, and this 3 becomes a 2. That's my gas. Carbon dioxide. We're all breathing it out right now. If I get H2SO3, it also gives off water. It decomposes to form water, and what's left? Well, again, we lose both of the hydrogens, we lose one of the oxygens. What's left? SO2. And ammonium hydroxide looks very different, but you can apply the same idea here. When it decomposes, it gives off water. So you lose H2O, and then you look at what's left. Like, well, there's the O, there's one of the H's, and if I change this 4 to a 3, that's 2 H's I've taken off. So what's left? Ammonia. And that's a gas. They got smaller and smaller, didn't they? This right here is not a huge deal. Titration, pretty big deal. Sometimes you have to pick and choose, right? Because you can't do it all even though you want to, even though you're capable of doing it all. You're like, I just can't learn all of this. This is something I give you permission to skip, okay? It's going to be like one question on an exam. So, writing equations for gas evolution reactions. Write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. We're going to apply the same process as we did for precipitation or for acid-base reactions. We're going to start out by writing down the formulas for the reactants. Hydrobromic, the hydro part tells me that this is not an oxyacid, so HBr, and aqueous potassium sulfite. Well, potassium sulfite is K+. Sulfite is one less oxygen than sulfate. Right? Sulfate was SO4, 2-. This is the light version, it's SO3, 2-. So to put those together, I get K2, SO3. The acid makes H+ and Br-. And we're going to swap the partners. See if any chemistry occurs at the beaker party. So I'm going to get K+ and Br-, and I'm going to get H+ and SO3, 2-. So I get KBr. We can predict that that's soluble, right? Because the first line of the solubility rules, lithium, sodium, potassium, and ammonium, always soluble. That's aqueous. And then this would be H2SO3. That is an acid, that's sulfurous acid. And that's going to be dissolved in water. Now, the title tells us, and the question tells us, this is a gas evolution reaction. So which of these guys looks most like the ones that were in the table? It's got to be this one, huh? So this is going to decompose. It's going to make water, and whatever's left after I take 2 hydrogens and an oxygen off of it. So I'm going to get these guys out of the way. So this is going to decompose. It's going to make H2O and SO2. So now I kind of have a mess. So let's write this out a little better. What's the state of water? Liquid. And the SO2 is the gas. Is that balanced? No, it's not. Which one jumps out at you as being a problem? The potassium. K2, just K. So that might be a good place to start. If I put a 2 here, now I've balanced the potassium. And I might as well look at what potassium is with here, is with bromide. So I've got 2 bromides. Over there I've only got 1. So I need to put a 2 in front of HBr. And then let's check sulfur. So here's sulfur and one sulfur. Let's check hydrogen. There's 2 hydrogens here, 2 hydrogens there. And the oxygen, there's 3 oxygens. There's 2 oxygens in the gas and 1 in the water. Balanced. Any questions?